Hi viewers, now we discuss the topic exercise 1.4 first section fourth one. Prove that root 5 is irrational. Clearly we know that root 5 is a irrational number. By we prove this one as in that indirect method proof. Solution proof we choose by using contradiction method. For that one purpose, let us assume root 5 is a rational number. Here rational number means it may be a number or fraction. So here we choose root 5 equals to a by b, where b is not equals to 0 and a comma b equals to 1. That means co-primes. That is meaning of co-primes. There is no common factors of both a and b other than 1. Apply squaring on both sides. That is root 5 whole square equals to a by b whole square. Now square and square root deduct. RHS side we have it is in the form of a by b whole power m. That equals to a power m by b power m. Right. 5 equals to a square by b square. Observe here 5 and b are transposed to LHS to RHS. That's why we get it here b square equals to a square by 5. So clearly we know that one theorem is there. If p divides a square, then p divides a. Or this can be also treated as a square divided by p, then a divided by p. So here p be a any prime number. That's why a square divided by 5, then a divided by 5. Clearly a is a factor of 5 and also a is a multiple of 5. That can be written as a equals to 5m, where m belongs to any positive integer. This solution continue as in next page. Put a equals to 5m in b square equals to a square by 5, where as in the place of a as 5m, that means a square means 5m whole square by 5. So 5m whole square can be written as 5 square into m square by 5. So 5 square can be treated as 5 into 5 into m square whole divided by 5. As in numerator and denominator 5 deduct, we get the value b square equals to 5 into m square. So 5 transpose to RHS side. That is b square divided by 5 equals to m square. Or m square equals to b square divided by 5. This is in the theorem, if p divides a square, then p divides a, where p belongs to prime number. Clearly here, if b square divided by 5, then b divided by 5. Clearly b is a factor of 5. So therefore both a and b are the common factors of 5. This is contradiction to our assumption, because a comma b are the co-primes. There is no common factor other than 1. We set it as in that starting. But what we get it here, a comma b are the both having common factor as 5. This is contradiction. Hence proved root 5 is an irrational number. I hope to understand this solution. Thank you for selecting my video.